Shaka Khan, welcome back. It's it's GameDevMicah again. I went ahead and accidentally hit pause on OBS right at the 20-minute mark, so what do you know? I guess we're cutting it 20 minutes. Welcome to video number 11. On number 11 here, we're going to go ahead and look at the same level that we just looked at in video 10, which was then using HLOD Merged Mesh, and had 100 extra megs on disk and about 10 extra megs on the file size. Let's look at the project size here. Oh, is this the right one? Just refresh. All UEFN props. No, it's not the right one. All ISM. Fortnite. Okay, so I get it now. In order for you to get your statistics, project size, in order for this to upload and be correct, you have to upload your project using the launch session. So hold on, let me hit launch session. Pause. Welcome back. Now you may have noticed that the numbers changed a little bit here because we went ahead and updated and we're in the session now. I'm Peter. Don't worry about it. So the shaders are now 2 megs, the level 1.3, and our overall upload, I'm guessing, is smaller too. I can't remember the numbers, but it's in the video. But you can see that the level is much smaller now because we're using instant static meshes for the rendering of level instead of that merged mesh and the custom meshes we learned about in video 10. If we go ahead and look in the viewport here, what you're seeing right here with the base we'll talk about because it's sort of an extra thing I'm doing. But to render the world, if we go ahead and hide everything, which we will, so we'll hide the blue base, the blue collisions, the green base, the green collisions, the ISM actors. So these are already ISMs. They're not part of the HLODs. They're just their own ISM or instant static mesh actors. Orange base, orange collisions, red base, red collisions, the trees and the rocks. Ooh, I did not include them in the... oh wait, yeah, I did. We'll see. So then we'll show the HLODs. We'll remove my animating stuff down here just to show it. So right here I have some UV offset world partition stuff going on to show how to efficiently show a bunch of moving icons using just material. They also get instance really well, so they're actually going to be in the HLOD or the world partition system. All right, there. So now I'll hide these two. This is what's the remainder in the world right now is nothing, just the floor plane and my 2 Niagara systems that are running. If we go ahead and turn on the instance, oh, they're gone. All right, so frustrating. When it loaded this level, it didn't load the ISMs. But funny part is, it did in here because we're actually playing the game. It doesn't. We don't render any of the non-ISMs or we're not rendering any of the real-world geometry. We're only using the ISMs. That's why you can kind of walk into it like this. And I have those custom blue collisions we saw, so that would stop the bubbling. So he's not able to walk into the wall here because I have a custom collision that's in there. We're rendering it using the HLOD system only. So everything in here is besides the Niagara systems is being rendered as an instant static mesh. And was either natively one when I placed it in the world myself, or I converted custom meshes I built into that. Now in the last video we looked pretty closely at these. I probably got at these slanted panels up here, the roof panels, and that can sort of show you how simple I made my meshes. So what I did up here, and for all of these, is I just took a square. I took some pictures of this mesh in the different viewports you can do, so a normal view, metallic view, stuff like that. And I made my own custom material, my own custom mesh, which is just a cube, and replaced all these, just to show the difference between ISM done that way and the impact on things versus a non-custom mesh where you can't do the instancing. So you can do Merged Mesh HLODS with any mesh, it'll work. You can only instance them if it supports instancing, which you may need to do with a custom mesh, just so you can click off enabled with instance materials inside of that material. I'll show you where that is. But over here, I'll reload this map. So we exit the session. We saw that the package size is much smaller, but without seeing the ISMs over here, it's kind of funny, right? But we just saw the ISMs when we baked in. So what I need to do is just restart the editor, and it should reload these ISMs. Sometimes it just freaks out and doesn't do it. Be right back. We're back, and guess what? I just reloaded it, and look what's there. All the HLODs, just like I said. Wow. So just reloading sometimes will fix your stuff. Reload. Same thing if you migrate stuff over to a different package. Don't just load the project in the editor, close the editor, reload the editor. It will refine the stuff, like the levels and stuff you migrated. The whole thing. Like we didn't cover exactly, when you build HLODs, especially the Merged Meshed HLODs, when you go and delete them, they don't get deleted from the project folder until you restart the editor and it reloads the project. So when you delete them, it's going to stay in the project. When you close the editor, it's going to stay in the project. It's going to take you reloading the editor and reloading that project for it to go through and delete the old HLODs out of the package. So be careful about that. If you're building the HLODs a whole lot in the same editor without closing it or restarting, you're going to probably see a bloat happening on your hard drive. And I'm sure the editor is having to consider all those files, so take a look. All right, so let's go back to the viewport here. We're going to go ahead and hide everything and turn it back on slowly. Let's just close it. Hide all the collisions, the base. Trees and rocks that get included are hidden. And the UV offsetting, the roll position. Vending machines will get rid of for fun. I don't want to look at them. Green base, green collisions, blue base, blue collisions. We'll leave the particle systems. All right. So there's the world. What we have in here right now is the two Niagara systems that I'll talk about later, probably in video 12. The trees that we added directly as ISMs, which we made an actor, added HISM to it, and these trees you can find in your, I have is these native ISMs over here that are excluded from HLODs. These just work as ISM. A large oak, as an example. Make sure it's recording. Static mesh right here is under Fortnite / environment / foliage. It will instance. The large oak and the pine tree will instance. How do I know that? We're able to add them to the ISM and see them. When you want to add pieces to this ISM, you can just add right here under instances. It has all the different instances list. So I have 101 of these trees. And I just added this one right here in the middle. Just clicked on it and I can move it around. I think, no, I didn't add that one in the middle. I added this one over here, which is at the center 00000 for where this component is, or this actor lives. Then you can just move the tree around. I don't know if these respond to, it doesn't look like they respond to snapping. So that might be a little bit of a pain. And they have to instance, and in order for them to instance, materials, you have to just come in here and click on the base material, come over here and type in instance, INS, and it says used with instance static meshes. Just needs to be checked off. If this was checked off on all the materials out there, we'd be able to instance everything, but it has to be instanced, or this has to be checked off in the material used on the object. Maybe if you can put the custom materials on them, that would fix it, but then you have to figure out how to line up those UVs and all that other stuff you're not given access to, which from the old textures. All right, so we hide these. So this is all the world that I built with ISMs. So the rocks and these trees and some of these smaller trees and smaller rocks are instanceable UEFN props I found or I think so. I think they're UEFN stuff. So I just put them in here. These do not need to be included in the HLOD system because the HLOD system would just convert these into the same actor. Because I only have one component rendering the oak trees here, that's as efficient as these oak trees are ever going to be. The CPU the GPU decides which ones get cold and which ones get seen, rather than the CPU. Standard actors are considered from the CPU, which is slower. All right, now let's turn on our HLODs. These are all other instance static meshes in each one of the cells. Doop. Ta-da! So our entire world is now made of ISMs. If I clicked on this, you could see, like we saw in the earlier one, we have about the cell size that's being shown. So it's making ISMs out of all these meshes per mesh, and then all these trees and stuff too. It's getting added to an ISM. How you can see this is by clicking on one of these cells over in the details on the side here. You'll be able to see what components it's made out of. So we do have they all say instance static mesh component. If you scroll down in here, the instances, you can see that in this cell right here, we're taking 460 instances, which is making up this for all these meshes, which would be the full floor mesh that I custom import, just as cube. We'll look at it right here. It's just these cubes, a full floor mesh, a ramp, and a full wall are the 3 custom meshes I made out of cubes. And I made them, I just took a picture of the actual static mesh I'm cloning and used that picture or a set of pictures to make them a material, which is this big, let me look at the material. Let's say it's this one. And you can see here, I just took in, this is the picture, the material. All right, and I'm changing red as my key to whatever color offset I want. And that's how I'm getting different colors for all the different places. You could pack more in to the other channels since I'm not using these other channels. And that could be where you put your other material if you do some material packing. My other picture, so I have a 1K file, or actually is it 512? Yeah, 512, 512, 512. This is where you tune it down as small as you can, because example here, 512 and 256 for my normal, another 512 for my roughness, and a 256 for the spectacular. These will probably all fit within a 2K amount of memory, 2x2, or 2000 by 2000, versus having one 2000 by 2000 texture. You know, if these were all that big, we'd need 4 times or more storage. So that's texture packing, texture reduction. Is figuring out how much detail you really need in this texture to drive what values it's putting into the material, and seeing how low you can make it so it looks good to you, or looks acceptable by the art direction. That's simple material, and now I'm changing the color. This material is instanceable, and so that lets all these buildings be ISMs. And those ISMs will then render as one draw call as long as it's one ISM on the GPU, and be also, like in this example, this one instance is making up for 460 static meshes that make up the building. The merge mesh does the same thing, as it takes this tile and makes it into a single mesh. That would be one single static mesh component over here, but a new mesh with a new texture, rather than just the same ones that are already in the package. That's the big thing to keep in mind, is that using ISMs, you don't have new stuff added to your package as heavily as you do when you make a new static mesh. There are some visual details that are not as good about the meshes I made versus the ones that are included in Fortnite, but that's up to you. You could import whatever type of static mesh you want here. The advantage with the instancing is going to be there regardless, as long as you're using more than 2 to 3 meshes in a cell or on a ISM component. We covered in one of the earlier talks about how each component itself has overhead. So a single static mesh, if you only have one of them in a cell, will be cheaper to render as a static mesh, or cheaper to store as a static mesh, because the overhead for ISM, instance static mesh, is about twice as much as a static mesh component. This is outside of the asset itself, the mesh, or the materials on it. It's just the overhead of the components that you're using, static mesh or ISM. Once you get to use 2 instances in an ISM, it becomes less overhead for the ISM, plus you get the rendering advantages. All right, so we have this world built out of tile sizes. Now, what I wanted to really show, and it's going to take a bit to build it, so I'm just going to tell you about it, is on my world, I have my loading range set to 0. Now this is something, now we're going to go into the, let's see how much time we got. I'm heading to a game dev meetup right now too, I'm late for. So we're into this video, I'm hopefully uploading it with little details, and now I'm skadooting. So we'll cover another one tomorrow. Oh, I wanted to have these all done. Another one tomorrow about this specifically, and also the Niagara systems and the world position offset I'm using here and the other cool things. But let's talk about the loading range real quick before I run away. So we have our 25,000 cells. And what this is trying to show you when you have it is the loading range. If I make the loading range 50,000, I can get, you know, pretty easily 2 cells loaded away from my dot here, which is where my player would be. If I make this 25,000, where you can see there's this little circle here that comes in, and that circle is kind of saying, hey, everything in this circle touches, we'll go ahead and load those. So we're loading this cell, this cell, this cell. What happens when you load? What happens when you load is that your merged mesh or your ISM that you're using, those go away, and we bring in the actors. If you built the world with HISMs, maybe those actors don't go away because they were ISMs anyway. But if they were actors that like can get hit, be spatially loaded, the idea here is you get rid of the efficient rendering and you bring the actors back. And when you unload these cells, you get rid of the actors and you bring back that efficient rendering, being the merged mesh or the HLODs, or ISM, sorry. And you also get rid of the actors out there. So if this is 1,000 actors that you're considering for replication, considering for damage, all that other stuff, when you unload them, those go away. You don't have to consider it. The server gets lighter and the client gets lighter. And it goes just to rendering visuals. That's the thing. Now what I've done is I went ahead and turned our loading range to 0. Now what this would mean is that if you have spatially loaded actors, they will not load. So this is a trick you need to think about if you want to use or not, because you would have to then have everything in here that, you know, is usable, like a door, loaded 100% of the time. So if we had doors in all these holes that we see here, the doors in the red base, the green base, and the blue base would be loaded all the time too, because we're never loading actors. We would just have to leave those non-spatially loaded so that they would function. Otherwise, if they're spatially loaded, they'd be removed. Now, why would we ever want to do this? Just to automatically convert your entire level to ISMs for you, and that's what this now does. We could do one large tile, so instead of 25,000, we can make this 100,000 maybe. We'll do 200,000. There you go. Now at 200,000, the tile will take over the entire island I got going on here. We're getting into really weird territory. You got to really know what you're doing before you start doing this crazy stuff, okay? Come talk to me. Think about it. This is extreme. When you make the entire thing into one tile and you bake this in ISMs, that means it will go ahead and make sure all these trees are rendered by one component. You'll only see one thing over here. But the nice part about that is that will be all the rendering will be handled on the GPU. You don't have to worry about there being 2 ISMs or 3 ISMs or 4 ISMs for the same mesh. So they're going to be guaranteed one draw call. This is extreme optimization. Now, when you do run it that way, you need custom collisions. The reason is I'm not seeing client-side collisions on these ISMs or HLODs. So what I did is I would go in, let's see, green base. Over here on green base, every base has this. I just turned them on over here. Turn off our preview grids. Is I added my own collisions. So you can see here it's just a cube that is not visible that I then put in place over the actual meshes that were created. Now you could hide all these meshes, turn the rendering off on them, and use the actual meshes that you already placed in the world as that collision, but then you get all those actors back. So I've simplified my actors per building. Let's see what we got here. And you could do these as ISMs as well. So that would be like the next step. But so these 66 collisions planes make up all the collisions that I want. And then I never load these actors. I use just the HLOD right up to the camera. No loading range. And what that's going to do is it will automatically instance your entire environment for you. But you still when you build your HLODs, but you still have the actors in here. So if I wanted to say, come down here and show green base, select a portion or a piece of the green base wall. I'll hide the HLOD for it. Boop. And move it. Then you could rebuild this and it would re-instance it for you. So it's a fast way. Of course, you'd have to adjust your collisions to get them nice and tight. Now that's if you collide with that area. So this all goes into you putting the least amount of data in possible. By having, you could turn off collisions now on this mesh, so that it never has collisions, because our collisions are always going to be this big blue plane right there that can go inside of it. And I've tilted it here too. This is unification. So rather than you have this one plane that the physics system's having to load in, so it does they always load it. So if you make these too big, they expand too long, you gotta try and keep them somewhat in a size like we are seeing here, where stuff's always loaded in that area. But it would replace 1, 2 by what, 10, 16 or something like that. So like 32 different collision checks here. Now we have one to tighten it up. Now these are extreme optimizations. Thanks for taking a look at them. There's another 20 minutes. That's pretty good timing. In the next video tomorrow, I'm going to hopefully finish this by going through and showing you how we're using a one texture to get multiple icons here. So one icon lookup, and then also how we're animating all this with WPO and without using Niagara. And then we have these two Niagara systems. One is a one particle times 1,000. The other one's one emitter with 1,000 particles, which is more efficient. So we'll talk about that. And then we'll talk about just comparing non-moving, which is just a little bit cheaper, versus the animating, just to proof it out. And these are actually part of the HLOD system that have been instanced for me as well. They don't instance as well to the merged mesh, but all right, thanks for hanging out. Look forward to talking to you tomorrow. Have a great night. Bye.